Hi, this is Soft Cell Electrical and I'm your host John. Today we're going to start on the last three formulas of 12 in the basic electrical formulas. This is the ohm series, and like volts, amps, and wattage, there are three formulas. Today we're going to focus on the simplest formula, and we're going to proceed to the next two formulas, which are going to get increasingly difficult. The ohms formulas lend themselves quite well to testing heating elements or verifying heating elements. The ohms formulas are perfectly suited for this kind of test. We will start simple and finish with a very complex real-time problem. Today's formula is volts divided by amps equals ohms or resistance. The standard space heater uses 12.5 amps and is powered by a 120 volt source. Now the motor uses 0.5 amps, so your actual value on the heater element is 12 amps. For ohms, just unplug the heater, turn the power setting to off, and test the coil for ohms. You should be getting 10 ohms. Looking at the formula, you just plug in the numbers. Very simple. Volts, 120 divided by amps, 12, gives you 10 ohms. Now this is not an exact figure. It will vary to some degree from unit to unit, but you should be getting really not much more than 10 ohms. 9.5 would be okay. 10 ohms would be perfect. If it's 12 ohms, I really wouldn't use the heater, and if it's 20 ohms, I'd toss it out. They're just too inexpensive of an item to be using if they're not working properly. So let's quickly review. We've got a space heater that draws 12 amps and has an input of 120 volts. Your nominal reading is 10 ohms. If you exceed that by much, it could be a loose connection or a rheostat. In this case, not, because we're testing directly on the coil feeds. If it reads something like 20 ohms, you really want to get rid of it. That finishes up the first of three applied ohms formulas. So stay tuned and put your thinking cap on, because the next two are gonna be tough. Thanks for watching and have a great day.